We'll try to understand what is Kubernetes. Okay, what are the features of Kubernetes, and then we'll see how can we deploy our applications in a Kubernetes cluster. So, what is Kubernetes? Kubernetes is a container orchestration engine. As we discussed already, what is orchestration? What is the meaning of orchestration? Right? It's a managing or controlling. So Kubernetes is orchestration engine and open source platform for managing containerized applications. Basically, it is going to manage container applications, whatever applications we have deployed as a containers. Like any other container orchestration software, like any other container orchestration softwares, the responsibilities of Kubernetes is basically container deployment. We can deploy the containers basically, scaling and descaling. We can scale up, we can scale down containers, and container load balancing. It can does container load balancing if we have a multiple replicas or multiple containers. So Kubernetes is not a replacement of Docker. As we already discussed, Kubernetes is not a replacement for Docker. Kubernetes can be considered as a replacement for Docker Swarm. Kubernetes can be considered as replacement for Docker Swarm. Kubernetes will manage Docker containers. Basically, to manage Docker containers, we are going to use Kubernetes. Kubernetes is more complex than Docker Swarm. It requires more work to deploy. To set up Docker Swarm, we have not spent a lot of effort. To set up Docker Swarm, we have not spent a lot of effort, right? If you see, Docker Swarm is embedded as part of Docker itself. Docker Swarm is pretty simple compared to Kubernetes. Kubernetes is more complex than Docker Swarm and it requires more work to deploy. But Kubernetes is very strong once we set up the cluster. Kubernetes is very strong once we set up the cluster. So who implemented Kubernetes initially? Right? So Kubernetes is implemented or developed by Google. Initially, Kubernetes owned by Google. It's developed by Google. Kubernetes is written in one language called Go language. Kubernetes is implemented by Google and they donated to CNCF. They donated to CNCF, Cloud Native Computing Foundation, in 2014. If you see most of the Google applications like YouTube, right? Gmail, OneDrive, most of the applications are basically deployed as a containers, and they are managing those containers using Kubernetes. So Kubernetes first version version 1.0 was released in 2015. Kubernetes first version 1.0 was released on 2015 July 21st, and the current stable release of Kubernetes is 1.18.0. The current stable release of Kubernetes is 1.18.0. So within this 5 years of time span, within this 5 years of time span, almost 18 versions got released in Kubernetes. Guys, first version of the Kubernetes is released in 2015. So from last 3-4 years, the containers and container orchestrations are in use. So what are the features, Kubernetes features? What are the Kubernetes features? As any other container orchestration software, automated scheduling. Automated scheduling. Guys, what are we scheduling in Kubernetes? Like what we are trying to schedule in the Kubernetes cluster? We are scheduling basically containers, our applications, which we packaged as a container, right? So in Kubernetes, we are trying to deploy our applications as a containers. So Kubernetes provides advanced scheduler to launch container on a cluster nodes. Kubernetes will schedule the containers on the cluster nodes or the cluster machines based on their resource requirements and other constraints. Automated scheduling. And self-healing capabilities. What is the meaning of self-healing capabilities? Self-healing. Self-healing, self-recovery, or fault tolerance. I can call it as a fault tolerance. So Kubernetes allow to replace or reschedule the containers. It can replace, or basically it will reschedule the container if container process is down. If container is not performing well, if container is not running, right? Kubernetes will replace or reschedule the container in the same node. If the node is healthy, it will replace or reschedule the container in the same machine if the node is healthy, or if the node itself is down. What Kubernetes can do, guys, like any other container orchestration in Docker Swarm also. What if the node goes down? What Docker Swarm used to do? The containers will be scheduled in containers will be scheduled in another node. Container will be scheduled in another node based on the node's availability. Similarly here, Kubernetes will replace or reschedule the container when the container is down or when the node is down. And also, we can roll out and roll back our applications. So we can deploy our application, we can update our application. If something goes wrong with your current version of your application, Kubernetes allows us to roll back. We can roll back or basically roll out the application. That we will see how to do that. And also, Kubernetes supports scaling. Scaling. Kubernetes supports scaling. While Docker Swarm also supports scaling, but what type of scaling? Docker Swarm, right? Kubernetes supports scaling, right? Manual scaling and also auto scaling. Kubernetes supports both manual scaling and auto scaling of pods. In Kubernetes, we will call it as a pod. I'll come to that what is pod. Basically containers. Kubernetes supports manual scaling and also auto scaling of pods. And also load balancing. Kubernetes can scale up, scale down the application as per the requirements. And also it will load balance the application. If there are multiple replicas, the Kubernetes will distribute the load. If there are multiple replicas for your application. And service discovery. As we discussed already, what is the challenges when we implement microservice architecture? As we discussed initially, what is difference between monolithic and microservices? What are the challenges we will be having in microservice architecture? If there are multiple microservices for your application, what are the challenges we will be having in a microservice architecture? Communication. One service has to communicate with other, right? So let's take this one as your application. And there are multiple services, multiple applications, multiple microservices you have. We already discussed what is microservice, what is monolithic. Now let's assume this is service 1. maybe like a login service, just to give an example. This is registration service. This is something like this, payments, orders, just to give an example. You have hundreds of services. So in microservices world, one service has to communicate with other service. Like one service has to communicate with other service. Now if you deploy these applications, right, as a container, the communication, how communication will happen basically? Normal for communication, right? Forget about containers. Your application is running on this. If it is a server or whatever it is, communication will happen based on the IP or host name and port. Based on the IP, host name and port. So the communication will happen with its IP and port, right? Basically, not only IP, the port on port where your application is running. So in a container world, there will be a multiple, your applications are running as a containers. And we have a scenario, you will have a multiple replicas. You have a multiple replicas. So it requires some kind of a load balancing and service discovery. What is service discovery? Can we depend on the IP address of these containers? Suppose this guy has to communicate with this guy. Can we depend on the IP address in a container world? No. Containers are dynamic. The IPs will keep changing. And also, what if there are multiple containers for the same service? What is required? Suppose this is trying to reach this one, and we may have a multiple containers for high availability. What feature we need along with communication? We need a service discovery, some and load balancing. Basically, load balancing is required between these containers if I have a multiple replicas. So Kubernetes supports service discovery and load balancing. We no need to worry about networking and communication. With Kubernetes, there is no need to worry about networking and communication because Kubernetes will automatically assign IP address and a DNS name for a set of containers. Kubernetes will assign IP address for your containers. And if there are multiple containers, we can access that containers using DNS name that will load balance the containers within the cluster. So when we access, right, in, in the Kubernetes, it can load balance the request between those containers. We no need to worry about networking and communication. Kubernetes has a service discovery feature. So Kubernetes will identify what is the IP of your container, and it can, it can start routing the traffic to that container. And also The storage orchestration, again, the volumes. So again in Kubernetes, we are running containers. Our applications again, we are running as a containers. What is the problem with container file system, guys? As we discussed, does container file system will be available outside of your container lifecycle? If container is deleted, do we have a container file system? So if your container is deleted, your container file system also will be lost. If you delete or if the container is crashed or deleted for some reason, the container file system also lost. So Kubernetes also supports volumes, storage orchestration. We can mount the storage of our choice with our containers. We can mount with storage of our choice, like we can use EBS, we can use NFS. Based on the provider, right, we can use appropriate storage of our choice. Storage orchestration. So Kubernetes has lot of features compared to the Docker Swarm, and again, why it is widely used container orchestration? Basically, it's an open source, one thing, it's an open source platform, and the community, the support. And lot of features are there compared to the Docker Swarm. So Kubernetes is widely used container orchestration tool compared to the Docker Swarm. Before we set up, Kubernetes, first we want to discuss about architecture, Kubernetes architecture. Very important. Before we try to set up a Kubernetes cluster, we have to understand the architecture and its components. So Kubernetes is again master slave architecture. Kubernetes is again master slave architecture. There will be a masters, there will be a slaves or workers. So master machines or masters will manage the containers which are running in these workers. So Kubernetes is master slave architecture. So there will be a masters and there will be workers. What are the components we have in the master and what are the components we have in the worker? So let's assume this is my cluster. Guys, what is cluster in general? Forget about Docker Swarm cluster or Kubernetes cluster. What is cluster in general? Cluster is basically a group, right? Group. So here, Kubernetes cluster, group of Kubernetes machines. So there will be a masters, there will be a workers. So Let me explain the architecture. I have some servers. These are some servers, physical machine or virtual machine. So we have a host operating system. We have some operating system, host operating system. So on top of it, you have a container runtime. You have a container runtime. On top of it, you have a container runtime. So what is container runtime, right? Docker. Here I am using Docker. So we have a Docker container runtime. We have Docker. Guys, Kubernetes supports other container runtimes also. Like Kubernetes can orchestrate other containers also. Like as I already told, containerization, Docker is popular. Like Docker, we have Rocket, RKT, or CoreOS. So Kubernetes can orchestrate these containers also. But widely used container tool is Docker. So we are discussing here Docker. So we have a physical machine or virtual machine, and you have a host operating system. On top of it, we have a containers. So here we have a container runtime software, Docker. But when we use Kubernetes, did we use any did we install any other softwares except this to set up a Docker Swarm cluster? When we use Docker and Docker Swarm, have did we install any additional softwares except this? No. Docker Swarm was embedded as part of Docker itself. Now when it comes to Kubernetes, we need Kubernetes related softwares on top of this to set up a cluster. Now, what is required? What are the components we have in the master? What components are required in the master? What components are required in the workers to manage the cluster? If you see in master machine, these are the components which will manage your cluster. In master machine, we will be having these components: API, server, control, managers, schedulers, and etc. So in master machine, these are the important components like API server, control managers, schedulers, and etc. These are master machine components. This we call it as a Kubernetes control plane, or basically master machine master components. So these are the control plane for our Kubernetes cluster in the master, which we will be having. In the worker machines also we will have few components. In the worker machines also we will have few components. If you see these components, kubelet and kubeproxy. Kubelet and kubeproxy. Kubelet and kubeproxy in the worker machines we have. In fact, in the masters also we will have. In fact, in the master also we will have. This will be we will be having in the masters also. But when it comes to the masters, we will more discuss about this API server, control manager, scheduler, and etc. So, what is API server? What is the role of API server in the Kubernetes? What is control managers? What it does? What is scheduler? What it does? What is etcd? And what is kubelet? What is kubeproxy? These are very, very important, guys. Before we try to set up the cluster, we have to understand the architecture, and it is very important in the interview perspective, and also as well as if you want to appear for a certification, Kubernetes certifications like CKA or CKAD. So we should more understand about the architecture, how it works, how it functions internally. So what is API server? What is the role of API server in the master, right? And what is kubectl? Kubectl is a CLI, guys. Kubectl is a CLI. CLI, command line interface. So I have a Kubernetes cluster. I have a Kubernetes cluster. If I want to do some administration task in a Kubernetes cluster, basically if I have a cluster, what we will do, guys, in a cluster? We will deploy our applications, we will update our applications, right? we will create a values, we will manage, right? So we are trying to schedule our applications. So using kubectl is a CLI, command line interface. I can manage or I can access the Kubernetes cluster. I can do a administration task in a Kubernetes cluster using kubectl or UI. But UI we will not use as part of CI/CD dashboard, Kubernetes dashboard. So if I want to do something, some administration task like creating a pods, basically containers, updating the containers, deleting or creating a volumes, any Kubernetes administration task we can do using CLI or UI. So it's a command line interface, CLI. Whatever commands we are going to execute, whatever commands we are going to execute, whatever you want to do in your cluster, what is the entry point for our cluster? So who will process our request, our commands here? I have a kubectl. If I execute some command, some kubectl related commands, Kubernetes commands, I want to deploy something, or I want to update something, or I want to create something. We are going to execute a kubectl command. Who will process that request, that command here, right? In this architecture. So in the master machine, we have a component called API server. In the master machine, we have a component called API server. So whatever commands we execute to deploy something in this cluster using CLI, when you are accessing using UI also, request goes to API server. So the master node is responsible for managing Kubernetes cluster. Master node is responsible for managing the Kubernetes cluster. It is the entry point for all administration tasks. In the master machine, we have a API server. As we discussed, in the master machine, we have a API server. API server is one kind of application which is running in the master. It's a front end of Kubernetes control plane. It's a front end of Kubernetes control plane. So communication center for the developers and system admins, right? So if I want to deploy something in Kubernetes cluster, I have to contact API server. If I want to update something, if I want to delete some application, I have to contact API server. So how can I contact API server? Using CLI. So this is the front end of Kubernetes control plane for all our administration tasks. It's a front end for Kubernetes control plane, communication center for developers and system administrators to deploy or to do some administration task. Our kubectl commands will be processed by the API server in the master. And what is scheduler here? What is scheduler? Basically, I want to deploy some application in this cluster. I want to deploy some application in this cluster. I will execute some kubectl commands. The API server will process that request, right? Let me take this way. Here also we will use some kind of a YML files case if I want to deploy something. I'll come to that what is pod and all. In Kubernetes also, we will deploy our applications basically using some YML files. We call it as a Kubernetes manifest. So this is my manifest, Kubernetes manifest. Let's assume this is my Kubernetes manifest. I want to deploy some container. I want to deploy some container. So when I execute this one, when I execute this command, I want to deploy some application in this cluster. So when I execute something here, right, this kubectl will request API server. The request goes to API server. So this API server will process this request. I am asking API server to create a pod. So what it does? The request goes to API server. API server first it will do. It will persist this information, the request in etcd. Kubectl. The moment I execute this one, request goes to API server. First it will persist. It will persist your request in etcd. API server is a front end of control plane. It will process your request. What request? The kubectl request, the administration request. It will persist that information in etcd. What is etcd now? Before I go to scheduler, what is etcd? It's a key value data store for Kubernetes. It's a data store. It's kind of a database. But is it our application database or it's a Kubernetes database? It's a key value data store for Kubernetes. It's a data store or database for a Kubernetes cluster. It's a key value data store for Kubernetes. What data it will manage? It will manage state of Kubernetes cluster. It will maintain cluster information like nodes, right? Nodes information, pods information, basically containers, It will maintain the cluster information, Kubernetes cluster information, etcd. So etcd is a data store. etcd is a data store for our Kubernetes cluster. So it will maintain the cluster information like nodes information, how many nodes are there, and pods, basically containers information. So first it will persist that request in etcd. Then scheduler comes into picture. What is scheduler? What scheduler does? What is the role of scheduler? The name itself is saying schedule. So what it will schedule, guys? It will schedule our containers. It will schedule our containers. So scheduler will watch the pods which are not scheduled. The scheduler, what it does, it will watch the pods which are not scheduled in etcd. It will check whether do we have any pods which are not scheduled. The scheduler will watch the pods which are not scheduled, and it will communicate with kubelet. The scheduler will communicate with kubelet. First it will watch the pods which are not scheduled, right? And the scheduler will schedule the pods. It will schedule the pods. So if you see, the scheduler will watch the pods and assign the pods. It will assign the pods to run on the specific nodes. Basically, the scheduler will watch the pods which are not scheduled, and it will assign the nodes. It will assign the nodes to those pods. So scheduler will talk to the kubelet which is running in the worker machines. Scheduler will talk to the kubelets which are running in a worker machines, and it will schedule the pods. So it will schedule the pods. Basically, what pod will have? Pod will have a container. Pod will have a container. Now we are trying to understand the architecture, guys. Later we will see how to create pods and all. So I want to deploy something. I will talk to the API server with my information. I want to deploy this one. With this information, I will execute kubectl command. The kubectl will talk to the API server. That API server will maintain the information in a etcd. Then scheduler comes into picture. Scheduler will try to schedule the pods by talking to the kubelet. It will schedule the pods. So pods has been scheduled by the scheduler. Now what is control manager? What control manager does? The name itself is saying control managers. There are lot of control managers, like we have a node control manager. We have replication control manager. There are lot of control managers. So node control manager, replication control manager, there are lot of control managers. The name itself is saying control managers. What it will do, guys? Suppose I have two replicas, I have two pods. The scheduler has scheduled two replicas because I requested two pods. So scheduler has scheduled two pods. It has scheduled two replicas. So if one of the replica is down, what replication control manager does? What replication control manager does? If one of the pod, one of the replica is down, one of the replica is down, what replication manager does? It will try to replicate. It will try to replicate. If one of the replica is down, it will try to replicate. The control manager will look after your pods. The replication control manager will look after your replicas. Similarly, like replication control manager, we have a node control manager. We have a node control manager. There are a lot of control managers. Each one will do its job. What node control manager does? What node control manager does basically? There are a lot of control managers, right? If you see node controller, replication controller, like deployment controller, there are a lot of controllers. So the replication controller, it will maintain the number of pods. If one of the pod goes down, one of the replica goes down, it will replicate. What node controller does? The node controller is responsible for noticing and responding when node goes down. Suppose one of your node goes down, the node control manager will do, it will respond. So node control manager will look after your nodes. Like there are a lot of control managers. So these are, we call it as a API server, control manager, scheduler, and etcd. We call it as a Kubernetes control plane or master components. These are heart of the Kubernetes cluster. These four are heart of the Kubernetes cluster. This control plane is managing your cluster. So coming to the worker machine, coming to the worker nodes, we have a kubelet and we have a kube proxy. Coming to the worker machine, we have a kubelet and kube proxy. In fact, in the master also you have a kubelet and kube proxy. So kubelet and kube proxy. What is kubelet? What is kube proxy? So we have a worker nodes. Worker nodes are the nodes where the application is actually running. Worker nodes are the nodes where our application is actually running. These worker nodes are controlled by master using what? These worker nodes are controlled by the master node using kubelet. These worker nodes are controlled by the master by using kubelet. This kubelet. The master machine will manage or control these worker machines using this kubelet process. So kubelet is what basically? Kubelet is like a node agent that runs on each and every node, and kubelet will make sure that your containers are running in a pod. So kubelet is a node agent which will run on each and every node. The master machine will manage the nodes with the help of kubelet. Kubelet is a node agent for your Kubernetes master. And what is kubeproxy? What is kubeproxy? It's basically a network proxy. Basically, it's a network proxy. Kubelet is a agent for your master. The master machine will communicate with kubelet to create a containers or to schedule the pods basically. So master machine will manage the worker machines with the help of kubelet process. And we have a kubeproxy. So kubeproxy is basically a network proxy and load balancer for that service, for the containers whichever we are running in that node, right? So kubeproxy is basically a network abstraction. Kubeproxy is basically a network abstraction in a Kubernetes cluster. So whenever we are accessing the applications which are running in a Kubernetes cluster, that will process by kubeproxy. First request goes to kubeproxy, then that kubeproxy will route the traffic to the appropriate containers, appropriate pods basically. So kubeproxy maintains the network rules on the work, those nodes. Kubeproxy will maintain the network rules on the nodes, and kubeproxy will allow basically network communication. So we can access our pods inside the cluster or outside the cluster with the help of kubeproxy. So it's a network proxy. Kubeproxy is basically nothing but a networking related stuff. If I want to access the application which is running within that cluster, inside the cluster or outside the cluster, that will happen via this kubeproxy. So these are the components we have in the Kubernetes cluster, guys. Very important in the interview perspective also. In the interview, they will ask, can you explain Kubernetes architecture? What is part of master machine? What is part of worker machine? What is API server? What is control managers? What is scheduler? What is etcd? What is kubelet? What is kubeproxy? Right? In an interview perspective also, it is very important. Now, if I deploy some application in the cluster, right? If I want to access the end users, if I want to access that application end users, if I want to access the application, right? We can access the application within the cluster or outside the cluster from outside, right? End users. It will happen via kubeproxy. We can access the application. Basically, the kubeproxy request goes to kubeproxy. Request goes to kubeproxy. This kubeproxy will send the request to the pods, appropriate pods. Kubeproxy will send the request to the appropriate pods. So kubeproxy is basically for a communication to access our application within the cluster or outside the cluster, it will happen via kube proxy. Kubelet is basically a agent for your master. The master machine will control these machines. It will manage these machines with the help of kubelet. So these are the components of your master. API server, scheduler, control manager, and etc. Now, let's try to understand the Kubernetes setup. There are multiple ways we can set up a Kubernetes case. There are different ways we can set up a Kubernetes cluster. Self-managed and managed Kubernetes cluster. Self-managed and managed. Self-managed Kubernetes cluster and managed Kubernetes cluster. So there are a lot of ways to set up a Kubernetes cluster. Like we have a mini cube. We have a mini cube. In the interviews, they will ask which Kubernetes distribution you are using. Which Kubernetes distribution you are using. You may get this question. Which Kubernetes distribution or like flavor, which Kubernetes flavor, right? So Kubernetes can be set up in multiple ways. Mini cube, single node Kubernetes cluster. Minikube, single node Kubernetes cluster. So do we use Minikube for a production? Like for our, in a production environment, can we go with Minikube? Not only production, for normal dev QA, right? It's a single node Kubernetes cluster. It's not for production. Production purpose, right? Not for production, for a normal dev QA also. So if you want to just explore Kubernetes, you can use Minikube. It is for kind of a lab purpose for exploring the Kubernetes. Single node Kubernetes cluster. And self-managed Kubernetes cluster. We can set up a self-managed Kubernetes cluster using Kubedium. We can set up a self-managed Kubernetes cluster using Kubedium. And we have a managed Kubernetes clusters. EKS, GKE, AKS, like IBM Kubernetes engine. There are a lot of managed EKS. What is EKS? Elastic Kubernetes Service. GKE. Google Kubernetes engine. Google Kubernetes engine. Azure Kubernetes service. IBM Kubernetes engine. There are a lot of like this managed. So we can set up Kubernetes cluster in multiple ways. Self-managed Kubernetes cluster, KubeDM. Minikube is not for our purpose, right? It is just like a set, lab purpose. We can set up using KubeDM, self-managed or managed Kubernetes cluster using these. And there is another way of setting up Kubernetes cluster in cloud, KOPS. Kubernetes operations using KOPS. We can set up production ready and highly available Kubernetes cluster in most of the clouds. Clouds like AWS. So KOPS will leverage cloud services like auto scaling groups and launch configurations to set up Kubernetes cluster, which is highly available. So basically using KOPS, I can set up a Kubernetes cluster. But what it does, right? Basically, it will create auto scaling groups. It will create auto scaling groups for your masters and workers. And it will create a launch configurations for your masters and workers. So KOPS we are using to create a cloud services like auto scaling groups and launch configurations for Kubernetes. So if I have a auto scaling groups for masters, if I have a auto scaling group for workers and its launch configurations in AWS, so who will take care the master machines and worker machines if master goes down, if worker goes down? Will it be recreated if I have set up a Kubernetes cluster using KOPS? Auto scaling and launch configuration concept in AWS. Suppose if I set up a Kubernetes cluster using KOPS, KOPS will basically create an auto scaling group for master, auto scaling group for worker, and its launch configurations in AWS. If master goes down or if worker goes down, do I need to worry? The machines. I am talking about the machines. So it will, AWS will take care. So we have a different ways of setting up Kubernetes cluster. Self-managed Kubernetes cluster, managed Kubernetes clusters, and I can use other concept like KOPS. So if I use self-managed Kubernetes cluster, I can set up a self-managed. The name itself is saying self-managed. If I set up a Kubernetes cluster using KubeDM, it can manage the pods. It can manage the pods. But what if your master goes down? What if your worker goes down? Do you get another master? Do you get another worker if you have a self-managed Kubernetes cluster? If I have a self-managed Kubernetes cluster, something went wrong with your master machine. Something went wrong with your worker machine. Your worker machine is down. Your master machine is down. Or the Something went wrong with your masters or workers. Will it be replicated? Will it be recreated in a self-managed? No. But if you have a self-managed Kubernetes cluster, you have a self-managed Kubernetes cluster, you have a pods, you deployed your applications as a pods. If pod goes down, will it replicate the pods in self-managed? Will it manage your pods and containers in self-managed? Yes. So self-managed Kubernetes cluster will manage everything, whatever it's supposed to do, whatever Kubernetes is supposed to do, it will do everything. We can schedule the pods. If pods goes down, it will recreate the pods. I can scale up, scale down the pods in self-managed also. But what if your machine goes down or your Kubernetes cluster is running out of resources? Will it create another node in a self-managed? No. The infrastructure, right? Infrastructure you are taking care. But if I go for a managed Kubernetes cluster, do I need to worry about my infrastructure? If something goes wrong with your servers, right? That will be taken care by the provider. The managed Kubernetes clusters like EKS, GKE, AKS. So EKS, who is offering this one? Basically AWS. In AWS, we have a one service called EKS, GCP, Google Cloud Platform, and AKS, Azure, Azure Cloud. IBM Cloud. So these are managed services. Which one we will use in real time? How can I say which one I will use? That is depends on your infrastructure. That is depends on your infrastructure. If your client is not at all ready to host the infrastructure in a cloud, can I use EKS? If our client is not at all ready to host the infrastructure in a cloud like AWS, Azure, so we don't have an option. We can go for a self-managed. We can manage the cluster, self-managed. And if client is okay to have a Kubernetes cluster in AWS, and again, if he is if he is okay to go with EKS, if I go with EKS, I will get lot of advantages. We can integrate with other cloud services, services like ELB, storage, like storage services, services like EBS. So if I go for a EKS, I can integrate our, we can use Kubernetes with other services like ELB, EBS, and other cloud services. But if I go for EKS, the charges will be little high, right? So first, we will see how to set up self-managed Kubernetes cluster. Then we will go for a other way of setting up Kubernetes cluster. So there are multiple ways to set up a Kubernetes cluster. Guys, if you just want to practice, you don't want to set up, if you don't want to install, if you just want to practice, we can practice using this URL. So there is a application labs-play with kubernetes.com. So you can log in with your GitHub or Docker Hub account. So you will get 4 hours time. You will get 4 hours time. You can create instances here, like you can create 2 instances or 3 instances, right? All the required softwares they have already set up, all the required softwares they already installed. You can create something like this, some instances, 3 instances. All the required softwares already they have installed. In one of the node, you just need to execute this kubdm init. You are initializing the master by executing one of the node. In one of the node, you can execute this command, this kubdm init in one of the node. So the master node is getting initialized. It will give a token. It will give a token and take that token and execute in these 2 machines. So this will become a master, other 2 will become a workers. So it will take some time. So the master machine is getting initialized. For practicing purpose, if you want to practice, you can practice. You will get some 4 hours time, 4 hours window. If you really don't want to create EC2 instance and set up yourself, but I recommend don't use this one. Whatever task you have already done, that will be lost if you close your browser or if this time is expired, right? Whatever you already deployed, that will be lost. Now, if you see, it has given a token. Take this token and execute here in these 2 machines. Let me copy. Now this will be joined as a worker here. If I execute here also, now this is also joined as a worker. Now if I execute here, kubectl get nodes, kubectl also installed in this machine. Kubectl also installed in this machine. Now I can see 3 machines. So if you see the instructions, what they told, initialize the cluster and create some network. Create some network. Basically, the network plugin, right? There are different networks available for your Kubernetes, like Calico, Flannel, View network, right? So we need to initialize the network. We need to deploy some network plugin also for our Kubernetes. So in this master machine, I'm trying to deploy network also. Once this network plugin is deployed, our cluster will be ready. After some time, you can see that cluster will be completely ready. It will take some time. So you can use this one for just practicing purpose. It is like a temporary machines. If you close this browser or if this time is expired, whatever you deployed, that will be lost. So you can use this one for temporary purpose to just practice. Now my cluster is ready. Once your cluster is ready, you can deploy applications, you can access applications and all. Okay. But I'll not suggest to use this one. So what we do, we will set up a self-managed Kubernetes cluster using KubeDM. First, to get started, we will set up a self-managed Kubernetes cluster using KubeDM. So tomorrow, I will continue with this. We will set up self-managed Kubernetes cluster using KubeDM. But just go through the video which we already have in our YouTube channel. So there is already a video available in our YouTube channel, Kubernetes setup. Kubernetes setup in AWS, EC2 instances, right? So try to go through this video, self-managed Kubernetes cluster using KubeDM. How to set up, we'll continue tomorrow. Okay. So try to understand the architecture. It is more important in an interview perspective. To get more knowledge in Kubernetes, we should have a understanding about Kubernetes architecture. What is there in the master machine? What is there in the worker machines? Right? And what is kubelet? What is kube proxy? What is API server? What is control manager? What is scheduler and etc. So tomorrow we'll continue with this. Guys, we will set up a Kubernetes cluster and we will discuss the Kubernetes concepts. Like Kubernetes, there are a lot of concepts. Like we will discuss what is pod, what is replication controller, what is replica set, what is daemon set, how to deploy our applications, how to access our applications within the cluster and outside the cluster, and how to use volumes. So in detail, we will continue. So first, try to understand the architecture and setup. We'll continue tomorrow, guys.